Hello and welcome to the House of Maths. Today we're looking at algebraic fractions and in particular division. So I've got two problems on the board here. Here's the first one, 3x plus 6 over x minus 4, and we're dividing by 2x squared plus 9x plus 10 over x squared minus 16. So quite a complicated little question here. But what we're looking to do is break it down into its simplest form. So what I would recommend to start with is to try and factorize as much of this as possible. So I'm looking at the top one here and I can see there's a common factor of 3. So I'm going to pull that out. That's going to give us x plus 2. So if we do 3 times x will give us 3x. 3 times 2 gives us 6. Underneath x minus 4, there's nothing we can do with that. So just put that in as it was. Now then, what we've got here is a quadratic and the coefficient here is a 2, so it's a slightly harder quadratic that we need to factorize here. So how do we do this? Well, the method I use, there are different methods, but I do 2 times 10 is 20. So that one times that one gives us this 20. And I'm going to use this 20 to help me break down this 9x. So I'm looking for two numbers that multiply together to give 20 and add together to give 9. So hopefully you can see that those are 4 and 5, plus 4 and plus 5. So we rewrite this 9x. So this bit stays the same. Then we're going to have our 4x and our 5x and still plus 10. So we've rewritten the 9x as 4x and 5x. So it's still, the two added together still give the 9x. I've put them this way round. Could have put 5x here and 4x there. It wouldn't matter, but the way I've done it makes life easier for us. And let's face it, in maths, we want to make things as easy as possible. So, because I can see we're going to factorize this half, and then the other half, and the 4 goes nicely with the 2, and the 5 goes nicely with the 10. So I'm looking for a common factor here, and hopefully you can see that's 2x. So factorizing is going to give us x plus 2, so 2x times x is 2x squared, 2x times 2 is 4x, and then our common factor here is 5, and in this bracket I'm just going to put x plus 2, that's what we should get, and then just check that it is right. So 5 times x is 5x, 5 times 2 is 10. Okay, then we can go ahead and simplify this. So this is going to work out at 2x plus 5 and x plus 2. So we factorize that. Now this bit underneath, we can factorize this as well. Now here, what you've got to spot is that we've got the difference of 2 squares here. So when we talk about difference in algebra, we're talking about subtraction. So we've got a subtraction here, and we've got x squared minus 16. Well, I'm saying it's a difference of 2 squares. What you're going to need to do is rewrite this as x squared minus 4 squared. So what we've got here, 16 is a square number. That's the giveaway as to what's going on here. That's why we've got the difference of 2 squares. So once you write it like this, you can see it's the difference of 2 squares, 2 square numbers, and we're subtracting. So you can immediately factorize this once you've spotted that that's what it is as x plus 4, x minus 4. So that's factorized. Now we've done this, I'm just going to copy this down underneath here. I'm not changing it. So what we've done to start with here is we've managed to factorize 3 parts of this. If you look at these as separate parts, 4 parts, we factorized this bit, and this bit, and here it is here. Now we can see what we can do, see if we can cancel anything out. That's usually what's going to happen next. Now, remember, when we're dividing fractions, what we really want to do here, like we would do with ordinary fractions with just numbers in, is we would keep this bit the same here. We would change this to a multiplication, and then we would flip these. So we end up with x plus 4, x minus 4 over 2x plus 5, x plus 2. So that's what we do with just numbers. So we do the same with algebra. Okay, there's no difference. Now, these are just multiples across here. This is 3 times this, times this, times this, and across the bottom, x minus 4 times this, times this. So we can cancel at this stage. So notice we've got x plus 2 at the top here and x plus 2 at the bottom. So they're going to cancel out. And notice over here we've got x minus 4 at the top, x minus 4 at the bottom here. These are going to cancel. So what are we left with? We've just got 3 at the top here, and we're multiplying it by x plus 4. And at the bottom, the denominator, we've just got 2x plus 5. So, as you can see, we've simplified this quite considerably by this stage. And we can't go any further than that. So let's have a look at the next problem. Similar sort of question, and we're going to approach it in the same way. We're going to see what we can factorise first. So looking at the top, I can see we've got 2 is common to both bits. So it'll factorise like that. Just check 2x, 2 times x is 2x, 2 times 1 is 2. X plus 5, can't do anything with that. Now we've got 2 quadratics. Now this is the easier sort of quadratic because it's just got a 1 as the coefficient of x squared. So all we're looking for here is 2 numbers that multiply together to give 3 and add together to give 4. So hopefully you can see that's 3 and 1. 1 times 3 is 3, and 3 plus 1 is 4. So we can immediately write that as x plus 1, x plus 3, and that's the top bit factorised. Now the bottom bit is the harder sort of quadratic, where we've got a coefficient greater than 1 in front of the x squared term. So remember, we do 2 times 15 is 30, and then we're looking for 2 numbers that multiply together to give 30 and add together to give 13. Hopefully you can see those are 10 and 3. So we're going to rewrite the middle term, so we're going to get 2x squared plus 10x plus 3x plus 15. And then we're going to factorise half at a time. So we got 2x here plus 5. So 2x times x is 2x squared. 2x times 5 is 10x. And then here we've got 3 as a common factor. And again, what's in brackets should be the same as what's there. So x plus 5. And then just check that it works. So 3 times x is 3x, and 3 times 5 is 15. So that's good. Then just finish this off. So we're going to get 2x plus 3 and x plus 5. So that's this one here factorised. Now I'm just going to write this out again, but I'm going to keep this the same. I'm going to change this to a multiplication. I'm going to flip these upside down. So you've got 2x plus 1 Okay, we're changing from division to multiplication. So these bits flip upside down. So we get 2x plus 3, x plus 5. And on the bottom, we want these two. Okay, so we've now converted that division into a multiplication. And all we need to do now is see what will cancel. So notice on the top, we've got an x plus 1. And on the bottom, we've got an x plus 1, so they will cancel. And over here, we've got x plus 5 and x plus 5 at the bottom, so they're going to cancel. So what are we left with? So I've got 2 there, and we've just got x plus 3 on the bottom there. So again, we've simplified that one quite considerably from our starting point. Okay, so just recapping, when you've got these kind of questions where you've got a mix of quadratics of various sorts, you're probably going to end up having to factorize first and then cancel. One thing just to point out again is look out for this setup, the difference of two squares. It's quite common in these questions and it's something you just need to spot. So the giveaway is that this number here is going to be a square number, and obviously you've got the x squared minus this square number, and then you can simply spot it and then factorize it immediately without having to do any workings, and that's really the key to it. Okay, so hope you enjoyed that. If you did, remember to hit the like button and consider subscribing. Thanks very much for watching.